Welcome to today's online class, children. The topic what we are going to see today, topics number 1 is refraction of light through a glass prism, and number 2, dispersion of light by the prism. Okay, so before going to this topic, actually first one is refraction of light through glass prism. Okay. Before going to this topic, let us recall that concept what you have studied before in the previous chapter. That is refraction of light through glass slab. Okay, refraction of light through glass slab. Here, what is that? Here it is the incident light. Okay, so this is the glass slab, and here the light, here it is the incident light, incident ray. Okay, and it is going from, see here it is rarer, and here it is denser, and here rarer. Correct? Rarer means what is it? Air. And here it is glass. And here once again it is air medium. Right? Okay. So the light is from entering into the glass slab. Okay. From air medium. Therefore rarer to denser. Therefore you know very well this is the normal. Okay. Therefore it bends towards the normal when the light is entering from rarer to denser. Okay. Recall what you have studied before. Okay, then after that it suffers one more. So this is the path of the that is, let me give some name to it, A, B, C, D. So AB is the incident ray and BC is the path of the ray that is inside the glass slab. Okay, so glass slab after suffering one reflection from rarer to denser medium, then once it comes to C, once again suffers one more what is a refraction. What is it? From denser to rarer, that is glass to air. Therefore when it is from denser to rarer, then you know very well it will be deviated away from the normal. So CD, that is the ray which is emerging after suffering two refractions through the prism. Okay, therefore this is your emergent ray. Okay, right. Therefore, this is, now if you extend the path of the incident, this is the path of the incident ray. This is the path of the incident ray. And if you see that the path of the emergent ray and the path of the incident ray, when you are extending, here it is the incident ray, but here say BE. BE, it is a path of the emergent ray when extended. Okay, so both, that is CD is the emergent ray, BE is the path of the incident ray, and both are actually parallel. Both are parallel. Therefore, which means that the light which is emerging from the glass slab after suffering two refractions, okay, its direction is just parallel to the incident ray. Okay, therefore this angle, what is that? This is the angle of incidence. Let me give some other color. Okay, and this is the angle of emergence, and you know that I, that is equal to E. Correct? Okay, therefore this is what you have learnt already, that is refraction of light through a glass slab. Fine. Okay, here incident and the emergent rays are parallel. The emergent ray comes out in a direction which is parallel to the path of the incident ray. Now we are going to see what happens when the light gets refracted through a glass prism. Now here also we are going to see whether, how about the emergent ray, how the emergent ray is coming out, whether it is parallel or not, everything we are going to see. Are you following, children? Right. Now going to prism now. What is a prism? See, I'll give you, this is, see, this is the prism. Actually, this is the prism Okay, therefore, how to here see a prism is nothing but a portion of a transparent medium. It is a transparent medium, glass. Okay, transparent medium bounded by two plane faces. Two plane faces. See, this is plane. Okay, the same thing if you want. Let me show this one side by side. The same prism here. Here it is bounded by two plane faces. These are all plane faces. This one and this one. Plane faces. Okay. Inclined to each other. Inclined to each other at a suitable angle. At a suitable angle. Are you following? See here, this is the glass prism. Here, what is that? There are two faces. Here, okay. It is the portion of a transparent medium bounded by two plane faces. Two plane faces. Let me give name. Here, actually, this is the prism. Okay. Here, it is a prism. If you want. Okay, let me. This is the prism. Here, actually, I am drawing it. How? See, the triangular face is to the front. Like that, I am drawing here. Okay, because here the other face is not shown. That is why I have drawn here. See, it is, let me give the name to it. It is A, and this is B, and this is C. That is a triangular face. This face, A, B, C. Because it is sidewise, I have drawn like this, so that you will be able to understand. Okay, and the next one is, here let me take B, Q, R. Fine. Now, see, therefore, this is the prism, okay, glass prism, and this is also a prism that is a tinted prism, slightly colored, okay, tinted prism. So, and now it actually, once again, I'll tell you what is a prism. A prism is a portion of a transparent medium bounded by two plane faces. ये तो plane faces है ना, इसमें ये की, this is P, and according to my diagram here, it is R. Okay, one of the plane, see, what are the plane faces here with respect to this diagram? Okay, A, P, Q, R, C. This is one plane face. Another plane face is, okay, A, B, Q, P. There are two plane faces are there now. Okay, are you following, children? So here, A, P, R, C and A, B, Q, P. Okay, or A, P, Q, P. A, P, R, C, A, P, Q, B. Okay, these two are the plane faces. Plane faces. And which are bounded by, which are inclined to each other, okay, at a suitable angle. This is that. Are you following, children? Therefore, once they are, actually you will be getting a triangular prism like that. One face will be automatically, it will be, what is that? Here it is triangle, and here also, that side also. This is the front side, and the back side of the prism will also be triangle. PR, there is one more face here. Are you following? Is it clear, children? PRQ. That PRQ hai na? Oh, that one, this, if you want, let me draw with one more color. See? Hai na? Okay. Therefore, that will also be, see, let me, triangle. That is a, it is triangle in shape. Correct? Therefore, see? Okay. Okay, there are two faces. What is that? Two plane faces, APRC and APQB. These plane faces are inclined each other by a suitable angle. Okay, at A, right? And there are, therefore, how many faces are there? 2, 1, 2, and also at the bottom. Bottom will also be there. There will be one more, what is that? Rectangular face and two triangular face. What is it? ABC and PQR. PQR is backside. Okay. Therefore, this front portion is ABC. Okay. Therefore, what is that? This flat a prism is a portion of the transparent medium bounded by, what is that? Two plane faces. Two plane faces inclined to each other at suitable angle. Okay, therefore, this face, this plane faces are there, no? What are they? This here, APQB and APRC. They are called as this face. Okay, they are called as refracting faces. This is what is called refracting faces. Here only refraction takes place. These two sides, the plane face is there, no? Okay, therefore there only refraction takes place. And this angle A, here hai na A, and this is what is called the angle of the prism. Okay, or it is also called refracting angle. Okay, angle A is what is called, that is the angle that is inclined by two plane faces. Okay, therefore that is what is called, either it is called refracting angle or it is also called angle of the prism. Are you following? Is it clear? Because here the other faces are not shown in this diagram. That is why I have drawn like this. I think you are able to understand how the prism will look like. If you come to the lab, no, once you come for a practical, then I'll show it to you. Okay, right. I think you can imagine now how the prism will look like. And this is also the prism. And it is a tinted, slightly colored prism. Is it called tinted prism? Got it? Okay. Therefore, this is very, very important. Therefore, a section ABC is there, no, here. The section ABC of the prism. Okay. Therefore, it is made by a plane at right angles to the refracting edges. Okay, and of the prism, and it is what the principal section of the prism, ABC, hai na? That is what is called principal section of the prism. Are you following? Is it clear? ABC, the section, that is a section ABC of the prism is made by a plane at right angle to the refracting angle. Okay, refracting angle of the prism, and it is what is called kya hai? Principal section of the prism. Okay, so ABC, that is, okay, that this ABC portion only will be shown while you are drawing the what is that, the refraction of light through the prism. No, that time you will draw only, you can show only this ABC only. You cannot show all these other faces, but you should know what is happening. This is only what is the principal section. ABC is the principal section of the prism. Actually, refraction is taking place only in these sections, but the plane surfaces P, APQB and APRC. That is why they are called refracting faces. Okay, is it clear, children? Shall we go to now? What is that? The refraction. Now, once you know what is a prism, how the prism will look like. Okay, now we'll go to refraction of light through the glass prism. Refraction of light through the glass prism. This one, you see. Now I'm going to show you. See, already this is the prism. That is how I think we have seen here. What are all the names given here? Okay, A. What is an A and B? Here it is C. Okay, this is the prism, right? Now in this, see, this is the incident light. Therefore, this light is here. It is the incident light. Okay, therefore this is the incident light. Incident light is falling on the face, that is AB. On the face AB. I told you only principal section is shown while we are drawing the ray diagram. Okay. Therefore, what is that? Actually, the refraction now, it is taking place in which face? ABPQ. ABPQ. So that I cannot show that. Okay, because it's 2D. So only this principal section is taken. Okay. Therefore, the light falls on this face, that is AB. Okay. Therefore, what happens? Ray of light actually suffers two refractions. Okay, this is how it is. One is from rarer to denser. On AB, when it is going, here it is a rarer medium. And this is a denser medium. Okay, that is a glass. Okay, therefore this is air. And this is glass. Okay. Therefore, as it comes, therefore you know very well, when the light is going from rarer to denser, it bends towards the normal. It bends towards the normal. Are you following? Therefore, let me towards the normal. How? See here. See here. This is the Yeah, because I cannot, yeah. See, this is the incident path, right? Incident path I am going to extend. Okay, why? Because extend the incident ray. Path of the, see, here I am going to extend the incident ray. Okay, this is the path of the incident ray, correct? Right. But what happens actually, it bends because it is suffering when refraction, no, because it is going from rarer to denser medium, therefore it will bend instead of going. Let me give you some name to it. Okay, here it is KL, it is L. Okay, and let it be, so you give some name to it, KL, L dash karo usko. Okay, L dash is the just extended path. If the light is not suffering any refraction, it will go in the path that is L dash. But it suffers some refraction at what is at the face AB when it is falling on it. It is entering from rarer to denser medium, so it bends towards the normal now. Instead of taking L dash path, it slightly bends towards the normal. Therefore, what is the path of the ray? Therefore, here see, it takes the path like this. Okay, see, it takes the path like this. Okay, right? Therefore, now you see, therefore this is the path of the ray. Therefore, here see it is, okay, this is what you give some name to it. Let it be LM. So, LM is the path of the ray inside the glass prism. So, after suffering only one refraction, which is refraction that is from rarer to denser medium. Okay, after that it goes from denser to rarer medium. Okay, why? Because it suffers one more refraction here. Are you following? When it suffers, see here, it falls at M. Okay, and here this is your normal, children. See, this is the first normal green line. This green dotted line is a normal. Okay, therefore, see, it is one at face AB and another normal at face AC. Okay, M is the point where the refracted light after suffering one refraction falls. That there, what is here normal is green. This is a green dotted line is a normal. So it goes from denser to rarer medium, right? Now it goes from denser to rarer medium. So therefore, what will happen? It bends away from the normal. Therefore, instead of going straight like that, it has to go like that. But it won't go. Are you following? Why? Because it is suffering refraction. Okay. Therefore, what it does? Okay. So, because it is suffering some refraction, one more refraction from denser to rarer. Okay, it is following the path that is Mn. After refraction, it follows the path that is Mn. Are you following, children? Therefore, now Mn, therefore it is the emergent ray. This is the emergent ray, the emergent. Here it is the, okay. Emergent. Are you following, children? So, incident ray, and this is the emergent ray. What is the path of the incident ray when extended? It will be going along L dash is going. What is the path of the emergent ray? Mn. Are they parallel as your glass slab case? No, definitely they are not parallel, correct? They are not at all parallel. Hope you are following, children. Therefore, incident ray. The incident ray suffers for actually first at AB, it suffers one refraction from rarer to denser. Okay, because of that, it bends towards the normal, takes a path that is LM. And at the M, once again, the face AC, it has to come out of the glass prism. Okay, therefore it is going from glass to air, therefore it is going from denser to rarer, therefore it will suffer a deviation away from the normal, therefore it deviates, and the final ray, the emergent ray coming out is Mn. Okay, therefore now incident and emergent rays here are not parallel, not parallel. Very important. Okay, therefore now we will see there is some angle of inclination between कौन सा है, the incident ray and the emergent ray. Now I am going to draw here. You see, it is, if I extend the emergent ray in the opposite direction, I am extending. Okay, I am extending the emergent ray in the opposite direction. Okay, therefore, now you see there is an angle of inclination between the incident ray and the emergent ray now. Okay, therefore this is the angle of deviation. Okay, and the angle of deviation, I think let me use, that is D, capital D. D I have not used anywhere, let it be capital. Are you following? Okay, therefore here, now you see what is the angle of incidence here, that at the face AB, there are two here, this is I, correct? This is I. Okay, and what is this one? This is angle of emergence. Are you following? And what is D? D is the this is what is called this D here. It is an incident ray, it is an emergent ray, and you know angle I, you know it is angle of incidence. Okay, and angle E is what is called angle of emergence. Are you following? And what is angle D is very important, is angle of deviation. Why angle of deviation? Why? It gives you the degree of deviation of the emergent ray, okay, with respect to the incident ray. It is the angle between the path of the incident ray and the path of the emergent ray. Okay, therefore incident and the emergent ray are inclined at an angle. What is the angle between the incident ray and the emergent ray? Okay, that is what is called angle of deviation. That gives you how the degree of deviation of the ray. Are you following? That is why it is what is called angle of deviation. It is not in the same direction, okay, but it is deviated from its original path, okay, by an angle, that is D. Are you following, children? Therefore, it is very, very important. And here, of course, it is angle of incidence. And see, there are, if you want to show, there are two refractions, right? One is here, let me give it in I1. If I give it this one I1, then what is R1 for the first refraction? It is angle between the refracted ray, LM, first refraction, no, first refracted ray, LM, and the normal, which is a normal, that's green now, therefore this is R1 karo. Are you following? Okay, I1, R1. This is angle of incidence and angle of refraction. R1 is angle of refraction. Okay, at the face, that is AB, first refraction. That is when it goes from rarer to denser medium. Are you following? Then after that it goes from denser to rarer medium. That time, this becomes the ray, incident ray. Okay, which becomes LM. LM is the incident ray for the second refraction from glass to air. Okay, therefore, that time you can say this is your I2 kar sakte hai na? I2, and R2 here is nothing but, what is R2? R2 is nothing but the angle between the emergent ray and the normal. That is nothing but E. That is nothing but E. That is angle of emergence. If you want, it can be even, it is, you can say that it is equal to R. That is equal to R2. Are you following? So it suffers two refraction. Okay, first the rarer to denser medium, angle of incidence is I1, angle of refraction is R1, and from denser to rarer medium, the angle of incidence is I2, angle of refraction is R2. Okay, as such. But in totally, if you see full path, full refraction, if you take, incident ray is KL, emergent ray is MN. Therefore, I can write what is that? This angle I1. Okay, if you want. Okay, I1. Okay, I1 is the angle of incidence, and our angle E is the angle of emergence. That is nothing but R2. Hope you're following. Is it clear? So overall, if I take both the refractions together, rarer to denser, denser to rarer, that time you can say even. Is it clear? I can say this one even I that. Okay, wait. Listen. This is I that is equal to I1. So I can even I that is equal to I1. Why I have written here? It is I is meant for overall refraction. If I take only one refraction, then you can say that is from rarer to denser medium. I can take this one I1 R1 and I2 R2. The second one is I2 R2. But if I take the full refraction of the prism, refraction of light through the prism, then I can take angle of incidence as I and angle of emergence as E. Hope you are following. That is why I have separated two refractions. If I take different refractions, then you can take I1 R1, I2 R2. Together, if you, what is that, the full refraction of light through the prism means angle of incidence you can take as I and angle of emergence you can take as E. Hope you are following me. Okay, so this is, and what about A here? This is very important, children. See what is A here? A है ना इसमें angle A. Okay, angle A is what is called, what is this angle? Angle A here is what is called this angle of the prism or refracting angle, both. Okay, angle of prism, or it is also called as refracting angle. Refracting angle. Are you following, children? Is it clear? So this is the actually, what is that? How the light suffers, okay, refraction when it enters into the glass prism. How it is actually in the glass lab also two refractions, rarer to denser, denser to rarer. The prism also two refractions, rarer to denser, denser to rarer. But there in the case of glass lab, both the incident and the emergent rays actually path are parallel, but here incident ray and the emergent ray are inclined at an angle that is D. That is what is called the angle of deviation. This is what is called angle of deviation. Is it clear? This is about refraction of light through prism. Next one will go. Next is dispersion of white light by a glass prism. Dispersion of light by a glass prism. Okay, well, how to understand this? What is dispersion first? Dispersion of white light. Here, see, it is a very interesting phenomena. This is actually a principle of, you can say, after that we'll be seeing all these applications. So, okay, the rainbow formation. Okay, so here a very important principle involved there is nothing but a dispersion. Okay, now first you understand what is dispersion. After that we'll go for the applications, right? Therefore, what is dispersion of white light? See, dispersion of light, it is, see, I asked you many times, you take a notes. Okay, I won't write the definitions and all here, so you have to understand and take the notes in your classwork side by side. Okay, so dispersion of light. What is dispersion of light? It is the phenomena of splitting off a beam of white light. Okay, splitting off a beam of white light into its constituent colors, okay, on passing through the prism. Are you following? Is it clear? Therefore, what is that? Dispersion of light. It is the phenomena of splitting off a beam of white light into its constituent colors when on passing through a prism. On passing through a prism. Okay, therefore the band of 7 colors so obtained here, okay, it is called this band of color, that is from red to violet you are getting now, that is what is called, this is what is called spectrum, and that is also, it is what is called visible spectrum. You can say that it is a, what is a visible spectrum? It is visible spectrum. Are you following, children? How nice. See, I thought of drawing in front of you, but it takes lot of time. That's why I drew everything. Okay, because the alignment, everything is there. No, it takes lot of time. That is why I have drawn before itself. Okay, just to have different colors are also shown. See, here, this is what is called dispersion. Once again, we will see. Once again, I am giving dispersion of light. It is a phenomenon of splitting of white light into its constant colors on passing through the prism. Okay, right. Now, what is the reason for this? Why? How? See, this is the prism. How nice. I will show you here. See. Okay, this is a band of colors. You won't see just ray like that. Okay, but you cannot show here. That is why I have seen here. This is how. Okay. Okay, so this is the band of colors you are getting right from where? Red to violet. Red to violet. So this is a spectrum visible. See here, this one I am showing it. Okay, this is the visible spectrum. Actually, the white light is not shown properly here. Get a white light and this will go after that only. What is that? It will undergo dispersion. Okay, so right, this is okay. Right, now shall we go for the cause of this dispersion? What is the cause for that? See, already you have seen the refraction. Well, what is the cause of refraction? Because when the light goes from rarer to one medium to another medium, okay, what happens is speed is changing, no? Speed is changing, its speed. Therefore, it suffers some change in its speed. Okay, therefore, whether it is going from rarer to denser means speed will decrease, and it goes from denser to rarer means speed will increase. Denser to rarer. Okay. Now, what is the therefore, because of that, see for example here also, what happens? The white light. When the white light falls on this prism, okay, now why, what is the need for, see ABC, okay, what is, see it is splitting, no, it is splitting. What is the reason for its split? Okay, it is splitting into 7 colors now. What is the reason? Because see, as white light has all the 7 colors, that is violet, indigo, blue, green, yellow, orange and red, all the colors. It's constant colors, but it won't be shown as it is when it is traveling in the rare. It is a rarer medium. Here it is air. Okay, and this is glass. Okay, as long as it is moving in air, no, what is it? It appears as white color only. Why? Very important. See, though it is having all the 7 colors, all the colors are traveling with the same speed. What is the speed of the light? 3 into 10 power 8 meter per second. So see, in a air medium, when white light is traveling, okay, it travels each and every color from red to violet. It is a constant. White light has all these colors, but all the colors are moving with the same speed, that is equal to 3 into 10 power 8 meter per second. Okay, but what happens? See, once it enters into the prism, okay, once it falls on the face, that is AB, and what happens? Okay, it is going to rarer to denser medium, that is air to glass. That time, what happens? See, different colors start traveling with different velocities. Are you following? As long as it is in air, so all the colors are moving with the same speed. But it is going from rarer to denser. Rarer to denser means definitely, in general, its speed will definitely decrease. It won't be 3 into 10 power 8 meter per second, because it is going from, as long as it is in air medium, it is 3 into 10 power 8 meter per second is the speed. Okay. But once it enters into glass, definitely, what is that? Speed will decrease. Definitely, you know, because it is going from rarer to denser medium. But how much is the decrease that matters? Decrease in speed is not the same for all the colors. Very important, children. Decrease in speed. See, you know very well, when it goes from rarer to denser medium, there will be some decrease in the speed. Fine. As long as it is an air medium, all the colors are moving with the same speed, that is 3 into 10 power 8 meter per second. Once it enters into the denser medium, that is glass, okay, therefore it suffers some decrease in the speed. But the decrease in the speed is not the same. If the decrease in speed is also same with for all the colors, okay, there won't be any splitting here. But here what happened? Decrease in speed for different colors are different. Okay, therefore, for decrease in speed for red is minimum. Decrease in speed, all the colors will suffer some decrease in speed. Okay, but the decrease in speed for red is minimum and decrease in speed for violet is maximum. Are you following? All are not suffering the same decrease in speed. Red color suffers the minimum decrease in the speed, and violet color suffers the maximum decrease in the speed. Are you following, children? Is it clear? Therefore, now you see, because red is suffering a slight, decrease in the speed, it will be deviated little. You see here, see, if you understand the concept and you learn physics, this is very easy, enjoyable subject. Okay, so you see here, this is the path you guessed. Let me give you the path of the light. A, okay, and not A. This is L or anything else. See here, K, L, okay, and it is L dash. Correct? So L dash is the original path. Okay, but here red color, you see, it suffers some deviation because red color suffers very little decrease in the speed. And next one is orange. Next more is yellow. Then which is suffering maximum decrease in the speed is violet. Are you following? So therefore red suffers minimum decrease, means therefore it is deviated to a little only. You see deviation of red. This is only deviation for red color, okay, deviation, how we have D. Okay, therefore deviation here, it is deviation for red color is this one. Okay, let me show with the red color itself. Okay, because you people, I am trying my best to make you understand. I don't know, this is A color, this one. Okay, this is, okay, D, deviation for red color. Okay, and you see violet ka dekh. See violet ke liye, see it is violet. Therefore, what is the deviation for violet from? It is the L dash is the original path. Okay, path of the incident light. Therefore, this much idhar se violet tak, hai na? That is your, what is the deviation for violet? Okay na? Deviation for violet. See, deviation for red is very less. Deviation, angle of deviation for violet is large. Why? Because red is suffering very little decrease in the speed when it enters from air to glass. But violet suffers a lot of decrease. Almost every color will suffer a decrease in speed. But for red, it is minimum decrease in the speed. But violet, it is maximum decrease in the speed. And intermediate color, if you go from red to violet, the decrease in speed is gradually, it will increase, and maximum speed decrease will be for violet light. Okay, are you following? Therefore, because they once they enter into glass, each color actually is moving, is traveling with different velocity, na? With a different speed, no? They are not moving with the same speed as they were in air, no? So definitely they cannot go together. They cannot go together. Okay, that is the reason why they are splitting. That is the reason why they are spending. Excellent, very wonderful concept. You see, as long as they are in air medium, all the colors are moving with the same speed. But once they enter into the glass, what is that surface? That is prism. Okay, different colors moves with different speed. As I told you, which will be moving with the maximum speed here. Maximum speed is speed of, you see here, very important. Why? See, as I told you, red suffers minimum decrease in the speed, violet suffers maximum decrease in the speed. Therefore, can you compare now my think these are just what is that? What is the speed of red light and what is the speed of violet light? Speed of violet light. Okay, so can you compare? Definitely, because red light suffers minimum decrease in the speed. Okay, and violet suffers maximum decrease in the speed. You know now very well this has to be more. Correct? This has to be more. That is why deviation, because red is suffering very minimum decrease in the speed, that's why it is deviated less. dr, it is the deviation for red, but violet suffers a lot of decrease in the speed when compared to its speed in air medium. That is why it is deviated a lot. That is this is angle of deviation for violet. Okay, therefore if you and other colors, right, from red to violet, the deviation will gradually increase. Okay, like that, if you see the velocity of red will be maximum and velocity of violet will be minimum. As you grow from red to violet, the velocity or the speed of light gradually, speed of light decreases, and it is minimum, speed is minimum for violet, maximum for red, and intermediate colors. As you go from red to violet, the speed will gradually decrease, but the deviation will gradually increase. Deviation will gradually increase. Is it clear, children? Okay, therefore you are get, that is the reason. Why? Because the speed is different. They are, as they enter into the glass slab, they move with the different colors. What is that? They move with different speed. Definitely they cannot go with each other. All will not go with each other because different colors are moving with different speed. That is the reason they split nicely. They split. Okay, red will be split at minimum, and orange next, yellow next, green more splitting, deviation. B next to that is deviation more for blue, then for indigo, and then for violet. Indigo, I am not getting the proper color, that is why I have drawn with this one. Okay, right. Is it clear? So therefore, if you are keeping a screen to the right side, see here it is. These are nice, how nice you see. Here, once again, you cannot extend this red, you listen, very important. This red light is there, no? Red light. After, what is that? They are splitted. All the splitted light is falling at the face AC. Are you following? When it is falling at AC, it suffers one more refraction. That is from denser to rarer medium. Denser to rarer medium means it will go away from the normal now. That is why there is one more deviation you see. Here, the light is from here to here. The light is getting deviated. Why? Because it is suffering one more refraction from denser to rarer. So, it goes away from the normal. So, that this is the path of the emergent light. Emergent, what is that? Colors, that is different colors. Red to violet. Are you following? So that is why you cannot extend. You cannot see. Listen, I am telling you, children used to make this mistake. I say, Hannah, for example, only extreme colors I will draw. ये तो red है. Okay, this is red. Just listen, why I am okay, this is the path of the ray, actual path of the ray, and here this is slightly, it is deviated as red, and here it is violet. है ना? Extreme rays only I am drawing in between all the other rays, right? Red and violet. You cannot just like that here, you cannot extend like this. Sorry, you cannot extend like this, red ray. Why? Because it is suffering one more refraction. Children usually they make mistake. Okay, here it suffers one more refraction from denser to rarer na. So you cannot just like that extend this. Here you have to slightly, once again it bends. Once again bends. Why? Because it suffers one more refraction. It suffers one more refraction. Is it clear? So slightly ये तो bend होना चाहिए इसमें. You cannot just like that. This light is for first refraction, and next one denser to rarer. Once again it suffers some bending, so it has to be like this. Okay, therefore you have to be very very careful in drawing the spectrum. It is not okay. If you understand the concept, it will be easy. You cannot extend just like that from the prism. इधे तो red light है. The red light you cannot just like that extend. Why? Because it's suffering one more refraction from denser to rarer. Once again it will be deviated. That is why here the path of the ray here after AC is slightly, it is bending na. Why? Because it suffers rarer, denser to rarer medium away from the normal. It deviates. Is it clear? Hope you are following, children. So this is what is called the visible spectrum. Whatever here it is a screen. This white one na, it is screen. I am keeping a screen. Once I keep a screen, I get a band of colors, nice, excellent colors. Okay, like this here. Okay, band of colors I'll be able to see, and that is what is called the visible spectrum. That is what is called a visible spectrum. Is it clear? Hope you are able to understand, children, what is dispersion. Once again, is it clear? What is dispersion? Dispersion of light is a phenomenon of splitting of white color into its constant colors on passing through the glass prism. The reason is when it goes from rarer to denser, the light, as long as it is in the rarer medium, air medium, white light is, all the constant colors are moving with the same speed. But once it enters into the prism, different color starts moving with the different speed. Such that red color moves with more speed, okay, and violet is maximum speed, and violet is moving with a minimum speed. Okay, therefore if I want to write, see, okay, I am trying my best to make you understand. I don't know what VR will be maximum, and next one is V orange. Okay, then next one is, what is the next? Descending order में जा रहे हैं. Velocity, speed. Okay. What is a V? It is yellow. Okay. Then V green. Then V blue. Then V indigo. Then what is that? Violet. V. Okay, so if I have today, which is moving with the maximum speed, hope now you are able to understand. Like that. Okay, that is why there is a splitting. That is why there is a splitting. Once they enter, the speed differs. Okay. Okay, therefore this is speed C. Here it is moving with the speed. What is the speed of the light here? Here it is C. But this will be less than C. Definitely. All the colors, or even the red light also suffers some decrease in its speed. Therefore, definitely, VR is moving with the maximum speed. Oh, sorry, here. VR is, that is, red light is moving with the maximum speed inside the prism, but that speed will be less than its speed in the air medium. That is 3 into 10 power 8 meter per second. Why? Because it is going from rarer to denser. Definitely it will suffer some decrease, but decrease in speed is least for red and the maximum for violet. That's it. That is the reason why the light is splitting. Hope you are able to understand. Is it clear, children? Okay. I am going to give two videos. regarding that is experiment how to do with prism experiment refraction, and also I am going to show in 2 videos. Okay, I'll be giving the link in WhatsApp group. Just go through once you first you go through this, okay, this lesson, then after that if you go through that you will be able to understand better. Is it clear?